Somewhere in the deepest reaches of the cosmos lies a monster. Slowly, it is pulling everything closer to it. Well, the only force that acts over such immense distance and through cosmic periods is gravity. So whatever it is, it's unimaginably massive. We call it the Great Attractor. It is something that makes all the galaxies in the known universe move towards a single point. But hold on, haven't we learned that everything is moving away from each other due to the expansion of the universe? So, how is this even possible? Today, let's talk about one of the greatest mysteries in space. So far, we know that the universe started with a singular event, which is popularly called the Big Bang. And since then, the universe is expanding at an accelerating rate. Every galaxy is moving away from each other with an apparent motion which is known as Hubble flow. This expansion and the stretching of space-time metric is leaving large voids between galaxies. In the 1970s, when scientists were studying the homogeneity of cosmic microwave background or CMB, which is the leftover signals from the Big Bang, they found that despite the overall homogeneous structure of CMB, there were few distinctly warmer and colder regions in it. When the universe began, the matter was distributed homogeneously, but over billions of years, galaxies converted into galactic clusters and then into dense superclusters, and they have immensely warped the space-time around them. These regions of merged galaxies give small inhomogeneities in the cosmic background, but due to large voids at other places, the universe is on average homogeneous.
Perfectly balanced, as all things should be.
This indicated that although the universe is homogeneous, it is hierarchical. Let me break this down for you. A galaxy consists of millions of stars. Nearby large galaxies are pulled towards each other at a much faster rate and are gravitationally bonded to each other to form a group. For example, our Milky Way galaxy, our galactic neighbor Andromeda galaxy, and the Triangulum galaxy are a part of the local group, gravitationally bonded to each other and falling towards a common focal point. This local group is 10 million light-years in span. Several such local groups form a bigger cluster known as the Virgo cluster, which is 65 million light-years in span. Similarly, many clusters form bigger entities known as superclusters. For example, Virgo supercluster and Hydra Centaurus superclusters. Virgo supercluster is in fact the arm of an even bigger superstructure known as Laniakea supercluster, which is home to nearly 100,000 other galaxies, including our Milky Way. Now, our Milky Way and the neighboring Andromeda galaxy fall towards the center of mass of the local group. Every other local group moves towards the center of the Virgo supercluster, that is, Virgo clusters, and all clusters move towards the center of the Laniakea supercluster. Thus, our universe that looks homogeneous on average is a collection of hundreds and thousands of such patches, which are themselves collections of thousands of galaxies. Studies in the 1970s and 80s suggested that the Milky Way local group was moving at a specific rate and in a specific direction in addition to the normal Hubble flow. Not only the Milky Way, but all nearby clusters were also moving towards the same direction. It's like some giant is sucking them up. This point of gravitational anomaly towards which all known galaxies were being attracted was later named, wait for it, the Great Attractor. I guess you can never beat scientists when it comes to naming things. The Great Attractor is nearly 200 million light-years away from us. From what we have discussed so far, we can say that the Great Attractor is not an object but a place, a center point of a patch of the universe. It is one of the biggest concentrations of mass measuring 1,000 trillion times the mass of the Sun and is located at the gravitational center of Laniakea supercluster. Sadly, it is hidden by our own Milky Way galaxy's galactic plane. So, the Great Attractor is difficult to observe directly in visible light wavelengths. In fact, it will not be for another 100 million years that Earth will be on the other side of the Milky Way galaxy, allowing us to see past the galactic plane. This makes the Great Attractor even scarier, since we can't see it. One question arises then. Will this attractor eventually consume everything up? The answer is no, according to our current knowledge. The Great Attractor is not stationary. It is moving like everything else in the universe under the effect of dark energy. Moreover, recent studies have suggested that even the Great Attractor is moving towards a greater attractor known as the Shapley Attractor, which is 650 million light-years away and has a mass equal to 10,000 trillion times our Sun, with the largest concentration of galaxies in our local universe. Now let me take a short break from these mind-blowing concepts to tell you about Rocketeers. Rocketeers make high-quality, affordable, and solid fuel-powered model rocket kits that even you can launch at your place up to the height of 800 feet. They are the first and only startup who are working on model rocketry in India with solid fuel power. While doing all of this, they've engaged more than 250,000 students and flown more than 150,000 rockets so far. They have also partnered with ISRO and created awesome merchandise to raise awareness about the works of ISRO. You can order these rocket kits and ISRO merchandise from their website rocketeers.in. Use our coupon code RWOS for an exclusive 15% off on all products. Link is in the description below. Now let's get back to our topic. Because the expansion of the universe is credited to dark energy, many scientists think that only something equally as dark could have the power to overcome it and form such a humongous entity. So, instead of a massive supercluster being responsible, it is a mysterious undiscovered force called the dark flow. The concept of dark flow, however, proves controversial as the distribution of matter in the observed universe cannot account for it. These events go against our normal understanding of the universe and raise hundreds of new questions. Still, there are brilliant minds constantly studying them and trying to get a better solution. These solutions bring us closer to reality. So what's your thought about the Great Attractor? Let us know in the comments. If you want us to keep creating such content, could you please show your support using the Super Thanks option below? Even the smallest contribution you can make will go a long way. It's supporters like you that help us make science more fun and easy than it has ever been. Also, don't forget to check out rocketeers.in to get your own model rockets to launch. These rockets can be reused a dozen times, so learn, build, and fly. Make sure you subscribe to the World of Science. Until next time, stay scientific.